Section 7.5 deals with proportions and similar triangles. And the first vocabulary term we're going to define is the midsegment of a triangle. A midsegment of a triangle connects the midpoints of two sides in the triangle. So if we draw a picture of a triangle and we pick any two sides and we put the midpoint on there, kind of like we did with the trapezoid, we mark the midpoint with tick marks on either side so that we know that it is halfway through and the two sides are congruent. We connect, and that is your midsegment. Okay, so triangle proportionality theorem. So if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So basically all that's saying is that if this line or this segment is parallel to this side of the triangle, then it divides the other two sides proportionally. So you could write a proportion RT over TQ equals RU over US. So example number 1, find the value of X. Because these segments are parallel, we know that the sides are proportional. So CD over DB would be equal to CE over CA. So this piece over this piece would equal this piece over this piece. So if we plug in, we get 4 over 8 equals X over 12, and we know how to solve a proportion. All we need to do is cross multiply. So if we do 4 times 12, we get 48. And 8 times x is 8x, and if you divide, you get x equals 6. Example number 2, we want to find the value of y. And so we look at these two sides that are parallel, so it divides the other two sides proportionally. So we could say PQ over QR equals PT over TS. So the first ratio in this proportion is very easy to plug into. 3 over 9 equals, we know that PT is Y, but now the question is, what is ST? Well, let's take a look. If the whole side SP is 20, and from T to P is Y, then ST has to be 20 minus whatever y is. So this is going to be 20 minus y. Solve the proportion just like any other proportion, and we will cross multiply. I recommend putting parentheses around the 20 minus y before doing so that when you cross multiply you get 3 times the quantity of 20 minus y equals 9y. Distribute, you get 60 minus 3y equals 9y. Add 3 to both sides, 3y to both sides, you get 60 equals 12y. And if you divide, you get y equals 5. So the converse of the triangle proportionality theorem is just exactly that. It flips the if and the then around, and it says if a line divides two sides of a triangle proportionally, then that line is parallel to the third side. So now what you would be given is this over this would be equal to this over this. So the proportion is true, so then you can assume these segments are parallel. So in example 3, we don't know if segment MN is parallel to segment GH. That's what we are going to test. So we are going to write a proportion, LM over MG equals ln over nh. Plug in, we get 56 over 21 equals 48 over 16. Now, you notice that there's no variable here. We are just testing to see if this is true. So what we need to do is reduce both sides. So on the left-hand side, 7 goes into 56 8 times, and 7 goes into 21 3 times, so we have 8 over 3 equals, If we reduce this side, 16 goes into 16 one time, and 16 goes into 48 three times. So the question is, are these equal? No. So MN is not parallel to GH because the sides are not proportional. Okay, the mid-segment theorem I have tweaked slightly here with the wording. If the segment connecting the midpoints of two sides of a triangle is parallel to the third side, then that segment is half as long as the third side. So basically, all you need to know is the mid-segment is half as long as the, in this case, side AB or BA, the side that it's parallel to. Okay, so in example 4, it says find QS. That's the length of QS, okay? Now, we know that QS, segment QS, is the midsegment of triangle PRT. Why? Because we know that Q is a midpoint and S is a midpoint because of the tick marks. If you know that QS is the midsegment, then QS is half the third side PT. So in this case, it's half of 10, so QS is 5. You are now responsible for, looks like 4 checkpoints this evening.